If you want to find information about Robot API, I can show you my approach how to find the most relevant sources. First one will be to find basically SDK folder. You can do that by typing SDK in your Windows, then going to the file location, again file location, and you are being pointed to the folder which contains a lot of information provided by Autodesk, README files, tutorials, samples, even some basic add-ins written in VBA in Excel. However, the most useful is the Robot API PDF, and I only look for information here. It's a very long and comprehensive PDF containing all documentation about Robot API, so this is the best source. And probably data server, iRobot structure will be the most relevant for you. iRobot structure contains all relevant objects in the robot model, bars, cases, nodes, and so on. Let's say we would like to create a new bar and we don't know how to do that. We can go to bars. We see that it's iRobot bar server, and this iRobot bar server contains fields and methods, and we can find relevant create method. We just go here and we can find that to call that method we need bar number, start node number, and end node number, and that's it. If we want to create another object, for example case, load case, we go to cases, iRobot case server, and here we can find a function to create simple case, which requires following parameters: number, name, case nature, and so on. And that would be the best approach to read and write Robot API code. To get familiar with Python syntax for Robot API interface, I would recommend going to PyRobot structural source code. You can do that going to GitHub, PyRobot structural, and then whatever is in your area of interest. Let's say it's a model and then sections. And here there are some functions to create custom tube section, custom rectangular section, a method to apply section to a bar, and for example load section from database. And let's say you are interested in this iRobot bar section data. So we can basically copy it, go to Autodesk PDF and search for this relevant field. And we can find here is iRobot bar section data, and it contains some fields and methods. And that will be the workflow to work with Robot API. Finally, I want to show you a simple beam example, which is a rough Python code interaction with robot without any additional packages. It just uses the PythonNet package, which is necessary to add DLL. Starting at the top, I provided some basic information. Then we are importing CLR, adding a reference, importing robot OM object, connecting to robot, creating nodes with node server, bar with bar server, labels. Then I used one of the existing predefined supports. Then I created a roller support, applying support to nodes, applying sections to bars, creating simple load cases, self-weight, live load, applying load, so just self-weight to all bars, applying basic uniform load, creating a simple combination, and then calculating the model, ignoring warnings, and lastly, displaying bending moments. Let's see how this example works. Creating a blank model and executing the script. And we can see a beam with bending moment was created. Right now, if you analyze the code, you can see that there is a lot of unnecessary text being written to create just simple objects. So for example, if you are calling enums, enumerators, types of nature and solver, you need to provide all of this text. And if you are getting objects from robot model, you need to cast them as the object type because Python will not see exactly what object type RobotOM returns. So idea behind PyRobot Structural is to provide you a clean wrapper which wraps internally all this unnecessary code and provides you a simple, clean Python functions which you can use and create your own models. I hope that example was clear and it will be useful. Thanks for watching.